So welcome you all again. So in one of my video we have seen that there is a clear difference between true and engineering stress strain curve, or we can say that there is a clear difference between engineering and true stress strain. Okay, so that we will see today. So the topic today is engineering versus true stress and strain. Okay, that is the topic that we will see today. So we know that engineering stress, that is equal to sigma, and that is P upon A, or we can say load upon the cross-sectional area, or we can say the resisting area to this load, and the unit is Newton per mm square. And engineering strain, that is epsilon, that is delta L upon L, or we can say change in length upon the original length. Okay, change in length we can get the final length minus the original length upon the original length, and this term, that is unitless term. Okay, so this is engineering stress and engineering strain. So when we have gone through this curve, okay, engineering and okay, and we have gone through this curve. Okay, here we are calculating the stress, engineering stress based upon this equation, where that A is the original cross section area, but that is not the real case, because as the load increases, the cross sectional area will decrease. Why? Because there will be the deformation in the specimen. So initially this might be the cross section area, but as the process goes on, the area reduces. Like this. Okay, but whatever stress we are calculating, that is based upon this formula, and that is original cross section area. So the cross section area is constant, that is the initial cross section area. So that's why we get this kind of nature of this graph, and this stress and strain, that is known as engineering stress and strain. But if we see the true stress, that is somewhat different. The true stress, that is load upon the instantaneous area, load upon the area, but that is not the original area, that is the at that instant of deformation what is the area is. So that is the, what we can say, the actual area. actual area while deformation at that particular instant. So we know that as the process goes on, the AI will decrease. Okay, the AI cross-section area will decrease because we are deforming the specimen, and that's why the cross-section area will reduce due to the deformation, and that's why we will have high value of true stress. So always remember that for any instant during the tensile test, true stress will be higher than the engineering stress. Okay, there is a clear distinct what we can say relation between true stress and engineering stress that we will see now. The true stress, that is equal to engineering stress into 1 plus engineering strain. Okay, and true strain, that is equal to natural log of 1 plus engineering strain. Okay, in this formula, this is true stress, this is engineering stress, this is engineering strain, this is true strain, this is natural log, this is 1 plus engineering strain. Okay, so there is a clear relation between the true stress and engineering stress, and true strain and engineering strain. So if you know the engineering stress value and if you know the engineering strain value, you can calculate the true stress. If you have only the engineering strain value, then you can calculate the true strain. Okay, and what is the formula for that? Okay, formula for that is load on area, and this is delta L by S. Okay, unit will be Newton per mm square, and this is unitless because mm upon mm, this is unitless. Okay, so this is the what you can say, the difference in the formula and the relation between the true and engineering stress strain. Now let us see what is the difference in the graph. Okay, now let us see that. So consider this x and y axis. Now here I will write strain, and here stress. Now I will not write engineering stress or true stress because we are plotting both the graphs. We are overlapping both the graphs. So let us see. Suppose this is the engineering stress strain graph. We know very clearly. And just consider, suppose the we have O. So OCS graph, that is the true stress strain diagram, and OF, that is the engineering stress strain diagram. So that is the difference. Okay, so you can clearly see this is the higher value in comparison to this lower value. This lower value, that is of engineering stress and strain. This higher value, that is of true stress and strain. Okay, so I hope this thing is clear to you. Engineering stress and engineering strain. This is not always you will get the nature of curve will be different for different material. I'm talking about the true stress strain value, true stress strain graph. But yes, definitely it will have near to this kind of nature, somewhat like this. Okay, so in different book you will find different nature, but that depends upon the material and also depends upon the value of engineering stress and strain. But more or less you will find this kind of nature for the true stress strain. Okay, so this is the very basic point. And if you are a mechanical engineer, be it let it be you are a degree engineer or a master degree student, you must know this difference, that what is true stress, what is true strain, and what is engineering stress strain. You know how you can calculate the true stress and strain from the engineering stress strain. Okay, so I hope this is clear to you. Keep watching and keep following Study HQ. I will come up with few more videos and interesting concepts regarding the mechanical engineering. Okay, thank you.